Hi friends, great welcome to our Gspace education platform. Today let we all know the interesting informations about Sun-Earth connection. Earth is illuminated and warmed by our Sun, which, as with every star, is a self-contained spherical nuclear fusion reactor. A small portion of the mass of the fusing nuclei transforms into tremendous amounts of energy, which is calculated by E equals mc squared, where E equals energy created, m equals the amount of mass converted to energy, and c equals speed of light. The surrounding plasma transforms the energy of fusion to thermal energy, and the warmed material convectively rises to the Sun's surface. As a result, the hot gas at the Sun's surface emits proportionately large amounts of thermal radiation at shorter wavelengths. Roughly 45% is visible light, 45% near-infrared, and 10% ultraviolet. It is Earth's relationship to the Sun, and the amount of light it receives, that is responsible for the seasons and biodiversity. The amount of sun a region receives depends on the tilt of Earth's axis, and not its distance from the Sun. The Northern Hemisphere experiences summer during the months of June, July, and August, because it is tilted toward the Sun, and receives the most direct sunlight. Inversely, summer for the Southern Hemisphere takes place during the months of December, January, and February, because that is when it receives the most direct sunlight. We are protected from the full blast of the Sun's violent activity by a dipolar magnetic field that diverts charged particles around the Earth and forms a cavity called the magnetosphere. When the Sun is near a lull in its 11-year activity cycle, magnetic waves formed by the Sun's interacting winds strike the Earth's magnetic field and connect with it, producing moderate geomagnetic storms and less brighter auroras. High-speed protons and electrons, generated during explosive solar activity, can cripple satellites and endanger spacewalking astronauts. Solar X-rays and extreme ultraviolet radiation both produce and significantly alter the Earth's ionosphere. The X-rays fluctuate in intensity by 2 orders of magnitude during the Sun's 11-year magnetic activity cycle, producing increased ionization, greater heat, and expansion of our upper atmosphere near activity maximum. This affects the ability of the ionosphere to transmit and reflect radio communication waves.